So in order to prove this one, again, choose the side you're going to start with. So the left side looked more complicated to me, so that's what I'm going to start with. It'll be easier to manipulate then. Now, the big indicator is you should notice we have a lot of squares in here. We got a lot of our tangent or our trig functions squared. So anytime there's something squared, one of our trig functions squared, I think back to my Pythagorean identities. Remember our main one, the only real one you have to memorize, is sine squared x plus cosine squared x equals 1. Because then I can get the rest. I can get the other one by dividing all this by sine squared. So sine squared divided by sine squared is 1. Plus cosine squared divided by sine squared is cotangent squared. 1 divided by sine squared is cosecant squared. So then that's my other one. 1 plus cotangent squared equals cosecant squared. Then my other one, I take my original and divide it by cosine squared. Sine divided by cosine, that would give me tangent, and it's squared. Cosine squared divided by cosine squared is 1. And then 1 divided by cosine squared is secant squared. So these are the three trig identities, Pythagorean identities, that anytime you see one of the trig functions squared, you should think, all right, can I use one of these? So the first one, I'm going to look at the top. 1 plus tangent squared. Hey, that's right here. I know tangent squared plus 1, or 1 plus tangent squared, all of this can be rewritten as secant squared, because they are equal. So my top I'm going to rewrite as secant squared. Then if I look at my bottom, I have sine squared x plus cosine squared x. Hey, that is our main trig function, Pythagorean identity, that we need to know. We know that's equal to 1. So all of this could be rewritten as 1. Well, then anything divided by 1 is just itself, so I end up with secant squared of x, which is where I wanted to end, so that proof is done. So number 10. Number 10, both sides look pretty similar. So if you want just to switch things up, I will start with the right side. So I'm going to do 1 minus sine. Actually, I don't want to start with that. I'm weird. I want to start with this. You could do it the other way. 1 plus sine of theta. I'm sorry, it's just weird. I like doing my left side first. It's probably because I read too much, so then I'm like, I gotta go from left to right. Alright, anyway, we're starting with this. I know I want to end up with cosine on the bottom and then the sine on the top. Now my problem is, I don't have any squareds. So I can't change cosine into sine because it's not squared, so I can't use one of those identities I just talked about. And sine squared, this isn't cosine because A, it's not squared. They need to be squared. So the only thing I can do, I want to get this so it's squared. So in order to get a sine squared, I'd have to times this entire bottom by what we call the conjugate, which remember is just where we switch that sign. If I times the bottom by that, I got to make sure I times the top by that, because 1 minus sine, over 1 minus sine, that just is 1. So I'm not changing anything. So, and that's because I knew I wanted to get this squared so I could change it to cosine. The other way to think about it is I know I wanted 1 minus sine of theta on top. So why not just times all of it by 1 minus sine theta? But then I got to do it to the bottom, so I'm not actually changing it. So then I'm going to actually go and solve. Since I want to end up with 1 minus sine of theta on top, I'm not going to distribute those. I'm just going to leave them as cosine times 1 minus sine of theta. And again, that decision was solely because I know I wanted to end with 1 minus sine. Now here, if I just leave these, that doesn't get me anywhere, so I'm actually going to FOIL these out. 1 times 1 is 1. 1 times negative sine is negative sine. Sine times 1 is sine. And sine times negative sine is negative sine squared of theta. Again, when I multiply it by the conjugate, we know that that's going to cancel these middle terms out, which is exactly what it did. So I still have on top cosine of theta, 1 minus sine of theta. And again, because I multiplied by the conjugate, this negative sign and this sine will cancel out. They always do. Those middle terms always cancel out when you multiply by the conjugate. So then I'm left with 1 minus sine squared. And right now, because we have that sine squared, you should have a mini alarm going off in your head saying, hey, let's see if I can use one of my trig identities. So, again, I'm going to rewrite it off to the side here. Cosine squared plus sine squared equals 1. Well, I have 1 minus sine. Well, I can get that just by subtracting that sine squared over. So then I'm left with cosine squared equals 1 minus sine squared. Oh, so that is an identity. I can replace all of this with cosine squared thanks to my Pythagorean identities. So, then I have cosine of theta, 1 minus sine of theta, over, we said we can rewrite this as cosine squared. Now at least I have the 1 minus sine of theta on top, and I have cosine on bottom. So what's going to happen is I have, and you don't have to rewrite this step, I'm just showing this step to you. For those of you who got a little confused in class why this worked, remember cosine squared is cosine of theta times cosine of theta. So then these will cancel out, and I'm left with 1 cosine on the bottom. So I get my final product, which is 1 minus sine of theta over cosine of theta. And that's the end of my proof because I got where I wanted to be. So then you'll put a little square saying check, done.